pretty easily, and then questions sort of 7, 8, 9 onwards are a little bit more challenging, but that's okay. We can either sort of address them today, or if we have time, I think we'll just go over the easy stuff today, and then maybe we'll get back next week. Okay, so this is the remainder theorem. If p of x is divided by x take k, so by some linear factor, and it has a remainder r, that means p of k is equal to r. I should use capitals here. It's the same, but it's denoted in your notes here. Okay, so if we have x to the 4 plus 3x squared take 2x plus 5, and we want to know what is the remainder when it's divided by x take 1. Okay, if this is p of x, we're going to find p of 1. Okay, we're putting the root into the polynomial equation. That's going to be 1 to the 4 plus 3 times 1 squared. Take 2 times 1 and plus 5. 1 plus 3 take 2 plus 5. We've got 4, 2, 7. Alright, so there we go. There's a quick way to identify the remainder. When we divide this polynomial by x take 1, our remainder is 7. Okay, and we're going to use that to solve for a. So we've got some polynomial here, but we don't know the coefficient of the x term. But we are told that when we divide it by x take 2, the remainder is 7. So that means p of 2, and we put 2 into this equation, that's going to be 2 to the 3 plus 2a take 5, that equals 7, because when we put 2 in, the remainder is 7. And we can solve for a accordingly. We'll have 8 plus 2a take 5, so we get 2a plus 3, 2a is 4, and a is 2. Okay, the next one tells us we have a polynomial, and we've got two unknowns this time. We've got a and b. It says when this polynomial is divided by x take 2, the remainder is 5, and when it's divided by x plus 1, the remainder is 10. So what this means is p of 2, when we put 2 into the equation, the remainder is 5, and p of minus 1 is 10. When you put minus 1 into the equation, the remainder is 10. Alright, so let's use these pieces of information to solve for a and b. Firstly, when we put 2 in, that's going to be 2 to the 3. Alright, so let's just deal with that one. So 8 take 6 plus 2a plus b is 5. We've got 2a plus b equals 3. That's our first piece of information. Next, let's put minus 1 into the equation. Deal with that one. We'll have minus 1 plus 3, take a plus b. Alright, and we could solve these simultaneously. I'm going to use my calculator just because it's faster and more mindless. So in the simultaneous equation, we've got two unknowns, and we'll just put, this is our first equation, 2a plus b equals 3. So we've got 2, 1, 3, and we've got minus 1, 1. Okay, and I've got a is minus 5 on 3, and b is 19. Okay, so there's going to be a fair bit of simultaneous equation solving, and when we have them like this, there's sort of sums, they're easy to put in the calculator. When there's products, then you sort of have to do a substitution. So I think when we can use our calculator, let's use our calculator. All right, so that's the remainder theorem. That's enough to get started on it. Good luck.